welcome back guys. So today we are solving the GFG problem of the day. It is stepping numbers, it is rated medium, and let's see what the question states. So before moving on to the question, I'd like to ask you to subscribe to our channel if you want every problem of the days of GFG and daily challenges of lead code to be solved, and all the contests of code forces, code chef, and lead code. The answers you will get here. Okay, so please subscribe. So let's move on to the question. The question states that a number is called as stepping number if all the adjacent digits have an absolute difference of 1. For example, 3 to 1 is a stepping number while 4 to 1 is not. Because in 3 to 1 all the digits have absolute difference as 1. But in 4 to 1, 4 and 2 have absolute difference as 2. So that is not. So we are given two integers n and m, and we have to find the count of all the stepping numbers in the range n and m. So if n is 0 and m is 21, then we have stepping numbers count as 13, because all the single digits are itself stepping numbers. So up from 0 to till 9 we have the stepping numbers, and 10, 12, and 21 are the three extra stepping numbers. Okay, because the difference is because the digit difference is absolute difference is 1. Okay, so for example, the second example is from 10 to 15 we have two stepping numbers that are 10 and 12. Okay, so let's see. So I guess you know the naive approach for this. The naive approach for this is we can traverse from n to m and check each for each number if it is stepping number or not. Like here I have my TLE solution. Okay, let's view it. The TLE solution, here I have traversed from n to m and I have checked for each I that if it is a checking stepping number or not. Okay, so if it is a stepping number, then I'm increasing the count. So how to check if it is a stepping number? Here I have stored a previous variable that stores the previous digit, and a current variable that stores the current digit, and I find the absolute difference. If it is not equal to 1, then I return false instantly. If the whole loop executes, then I don't find any case where the absolute difference is not equal to 1, then we return true for it. Okay, this is a naive approach. I guess everybody can do it. Okay, so let's move on to the optimal approach. In the optimal approach, we have used DFS. Okay, the DFS algo. So let's see what we have done. So first we send all the single digits from 0 to 9. Suppose we send 3. Then we first check. Suppose here we send 3. Then we first check if it is in the range n and m. Okay, here we have checked if it is in the range n and m. Then we increase the count by 1. Okay, so after 3, let's here we store the last digit. So for example, here the last digit is 3 itself. 3 modulus 10 is 3. So after 3, what are the stepping numbers we can get? After 3 we can have 34 and 32. Okay, so I have done here I into 10 plus last digit plus 1. So 30 into 3 into 10 is 30 plus last digit, that is 3 itself. So 33 plus 1, that is 34, and we get here we get 32. 3 into 10 30 plus 3 33 minus 1 32. Okay, so if the so that's it, we go on calling further. For 34 again we call, and then for 32 again we call. For like 32 we can have 321, and for 34 we can have 345. Okay, so similarly we do this DFS and we get our answer, and here we return the count for uh, all the valid uh, stepping numbers. Okay, so finally we return the count. So that's it. Let's submit it and see. Yeah, it works fine. Thank you.